Hello. So today the topic of our discussion is potential at any general point due to a dipole. So we will suppose this is our dipole whose length is 2a, that we have 2 points A and B. At these points, like at A we have minus q charge and at B we have plus q charge. This is the midpoint of this dipole. The direction of dipole moment is from negative to positive charge. This is suppose this is the point P. At this point P, we want to find the dipole electric potential due to this dipole. Join this A to P. This is R1. Similarly, join B to P and name this as R2. Join this P to O. Let this angle be theta. Now draw a perpendicular from this point B. From this point B, drop a perpendicular on this line AP such that this PR is equals to PB. So we can write AR as AR is equals to this R1 minus R2. The potential because of this minus Q charge is equals to K minus Q by R1, and potential because of plus Q charge is K plus Q by R2. Because in potential we take charges with their sign. Net potential at this point P, V net is equals to V because of plus Q charge plus V because of minus Q charge, and V because of plus Q charge is K Q by R2. This is minus K Q by R1. Take their LCM. So take K by common and we'll write it as 1 by R2 minus 1 by R1. Now take their LCM. This is R1, R2, and this is R1 minus R2. Uh, in this triangle, in this triangle, let this angle, if this angle is theta and this angle will be 90, so this angle will be 90 minus theta. In triangle ARB, sine 90 minus theta should be equal to AR by AB, and AR is equals to R1 minus R2, and this AB is equals to 2A. So we can write it as sine 90 minus theta is cos theta is equals to R1 minus R2 by 2A, which is equals to R1 minus R2 is equals to 2A cos theta. Suppose this point P is very far away from this dipole, so we can consider this R1 is nearly equal to R2. So we can replace this R1 times R2 with R square. Now placing these values, these value in this equation, we can get it as V net is equals to KQ. In place of this R1 minus R2, we can place 2A cos theta, and in place of R1, R2, we can write it as R square. So it will be KQ times 2A cos theta by R square, which is equals to Q times 2A is dipole moment. So it is Kp cos theta by R square. This K can be opened as 1 by 4 pi epsilon naught P by R square cos theta. This is the net potential at this general point. Thank you for watching.